The last session, we were discussing about the data center evolution. So in this lesson, we'll understand the fundamentals of cloud computing. We'll understand cloud models and cloud types. Could be a small session. So as we recap the last session, data center evolution. So initially they were physical data centers where all the components in the data center are basically physical. And on a physical server, we deploy an operating system and applications. So more of like in one server is dedicated to one application. So the physical data center consumes a lot of space, generates a lot of heat, requires a lot of cooling requirements, then basically higher electricity bills. And slowly the industry moved into virtual data center. So where we would see that on top of a physical server, we have a virtualization software. That virtualization software will create a virtual hardware and a virtual machine. So on top of a physical server, we can run multiple virtual machines, nothing but a virtual servers. So this virtualization help the organizations to reduce the number of physical servers required in the data center and better utilization of resources. So in the physical data center, if the physical server is not consuming, the application is not consuming the physical resources, so it is basically sitting idle. So in virtual data centers, what happened is, so we can create multiple virtual machines till we manage the performance. So initially, when we set up a server, we might have created 3 virtual machines. Then we see that the physical resources are being used only at 30%. Now another 60-70% are idle. So as we get a requirement, we can deploy multiple virtual machines. So that way, what happened is the virtualization helped us in better utilization of resources and faster deployment of virtual machines or basically servers in the data center. Because as it is a software, we can just say right click and create a new virtual machine. In less than 15 minutes of time, we have a virtual machine up and running in the data center. That's where people have seen much benefits with the virtual data center. And it's not only server, the virtualization has virtualized the basically created in a virtual networking devices like virtual switch, virtual router, virtual firewall, the virtual tape libraries, virtual storage devices, virtual hard disk. So everything got virtualized in the virtualization data center. Because, however, this virtualization needs a physical resource, but less. I would say called as the number of devices are less. Slowly, industry moved into cloud data centers. The cloud has become only called as a self-service. So the underlying on top of the virtual data centers, so built called as a self-service. So where the users need not to depend on anyone. So we can interact with an application, a self-service application, and we can request for number of virtual machines. We can request for network creation, everything. And the self-service will takes care of deployment of resources in the data center. That's what we see today. The data centers are basically we're calling it as a cloud. Let's see more from the cloud data centers and different types of models available. Okay. So typically when we call it as a cloud computing or a cloud data center, it is an on-demand self-service. As we were talking about a self-service data centers. So on demand, whenever we want to create resources, we can just interact with the self-service portal and create a number of resources. However, there will be some kind of limitations or limits, a quota which is being assigned. But within that particular quota, we can create our own resources. Broad network access. Already these cloud data centers are being connected to the internet. So again, we don't need to establish an internet connectivity to these data centers or to the virtual machines or to the applications which we deploy on the cloud data centers. Resource pooling. So the cloud data centers are basically resources like the servers, network devices. Okay, when the capacity is getting full, there is basically resources which gets adding into this one. And this provides a rapid elasticity. What is that rapid elasticity? The good thing about cloud data centers or cloud computing is in today I have a virtual machine with a two process with 4 GB RAM with a 512 GB of hard disk space. I want to add another hard disk. On the fly, I can add an hard disk. I want to increase the number of process from a 4 process to 8 process. I can increase the process. I want to increase the capacity of RAM from a 16 GB to 32 GB RAM. I can increase the capacity. And I see that, okay, I allocated 8 process with a 32 GB of RAM, but I see that it is not using the capacity. I can scale it down. I can reduce it from an 8 process to 4 process. I can reduce it from a 32 GB RAM to 16 GB RAM. Now the cloud computing provides an elasticity. As and when you need it, you scale up, you create resources, you upgrade them as you need it. When you really don't need them, you can basically shrink it or you can reduce them so that you can save cost or you can save resources. And the cloud data center called as a metered service, measured service or a metered service, we call them as a measured service. What is this now? We are giving a self-service. So in a simple example, I will case that I'm giving a credit card to my son. So what happens here now if I give a credit card to my son? He can use it the way he want to do it. He can use it in a proper way or he can use it in a wrong way and misuse it. So at the end of the day, I need to pay the bill if he misuse it because there is a cost associated with that for all the things which he purchased it. Now what I need to do now? Here I need to tell how much amount of money you spent on clothes, how much of money you spent on your books, how much amount of spent on your food or entertainment. Like basically we track it. Similarly here, the cloud data center is providing us a self-service. It means that we can create a number of virtual machines. We can create X capacity of storage. We can consume GBs of RAM like these things. But at the end of the day, they're all being calculated and monitored and basically charged. So you will see that, okay, today I'm creating a 10 virtual machines with the 4 processors and 16 GB RAM. So I'll be charged for a 10 virtual machines for 4 processors. So whatever we do it on a cloud, everything is being metered. It's just like a taxi. Okay, how long you go, you pay that much. So you travel for a 2 kilometers, you pay for a 2 kilometers. You travel for a 10 kilometers, you pay for 10 kilometers. You travel for a 30 kilometers, you pay for 30 kilometers. That is a taxi, a metered taxi. The cloud computing is also a metered service. So the cloud is going to monitor what type of resources you're creating and what is the cost of each and every resource. And end of the day, you are being accountable for basically consumption of those resources. That's where this is giving a flexibility. Yes, customers can come and basically use the cloud and they're responsible for paying that bills for the consumption. Okay. So that's the benefit of cloud computing today, what we see called as a cloud data centers. But now there are different types of basically models in the cloud. Now we see Microsoft, we see AWS, we see Google, we see Oracle, okay, we see IBM. Like there are so many vendors across the globe okay, who are providing the cloud services. Cloud services. Now, what type of services they are providing it? So we call something called as in cloud models, which differs basically based on requirement to the requirement. So we use something called as an on-premises. So technically, this word may get confused. So we can call it as an our own data centers. Okay. So in a simple way, call it as our own data center, which is called as an on-premise. It means that I'm setting up a data center in my office premises, which I'm calling it as an on-premise. So nothing but this is a cloud data center, which I'm setting up in my office premises. Now, what challenges we have here now? Now, when we set up our own data center, so we are responsible for the physical infrastructure, like the servers, the network devices, okay, storage devices, like power, connectivity, okay, cooling. So when we set up our own data center, we are responsible for everything. That physical infrastructure, which is all servers, networks, storage, power, connectivity, cooling. If there is some issue with the physical server, so I coordinate with the hardware vendor like IBM or an HP or a Dell or a Cisco, then I get the result. There's some issue with the network, then I basically some issue with the connectivity. So I coordinate with Reliance or a Tata or a Sifi or someone who is providing the connectivity, then we do that. And we are responsible for the virtualization infrastructure, because it's our own infrastructure. So as it is our own infrastructure, so we are responsible for managing this virtualization infrastructure. Now, whatever that virtualization infrastructure which we built on top of the physical infrastructure, we are responsible for maintaining. Then we are responsible for the operating system and applications and middleware, whatever we call it as, and everything I would say called as a middleware, etc., etc. We are responsible for everything. We are responsible for everything. So when we set up our own data centers, which we call it as on-premise own data, we are responsible for the end-to-end, okay, setup, maintenance, and manage the data center. Now we are talking about something, a Microsoft Azure, AWS, Google. Now what does this now? That is not our data centers. So when we go to the another model called as a cloud called as infrastructure as a service. So what happens in infrastructure as a service? Provider. Who is provider here? Microsoft Azure, AWS, Google, Oracle, IBM, or whoever basically the providing the cloud data centers. We call them as providers. So in the infrastructure as a service, if a cloud data center is being provided, now they are responsible for the physical and virtualization. So now what happens here now? These people are responsible for the physical infrastructure and virtualization infrastructure. virtualization infrastructure. So they are building a cloud data center and giving us a self-service portal. So now they are responsible for to ensure that the physical infrastructure is up and running, which includes the servers, network, connectivity, power, cooling, and everything they takes care of it. And top of that, the virtualization infrastructure will be taken care by them. So they provide and basically an infrastructure. On top of that, we create our own virtual machines. We are responsible for. So when I create a virtual machine, so the virtual machine has an OS, operating system. Then it has some basically some applications. It has some data, application data. Now we are responsible for the operating system, applications, and data. So if you create a 200 virtual machines or 300 virtual machines on a provider, a cloud data center, now they are basically maintaining the physical infrastructure and virtualization infrastructure. Now, if we create 100 virtual machines, we are responsible for managing the operating system, which is sitting inside the virtual machine. And we are responsible for managing the applications. And we are responsible for the data. So they're just providing you an infrastructure, which is required to run virtual machines and run your own applications and data. So the advantage here is we don't need to bother about the physical data center maintenance, the physical servers. No need to coordinate with an hardware vendor. No need to bother about the failure of the hard disk or these things. No need to bother about the power failure or a connectivity failure because the vendor who's providing that service is going to manage that. Now, advantage for me is I manage my application. I manage my data. I manage my operating system, everything. But the data center is someone else. So on top of that, I'm running it. So this kind of a service is called as an infrastructure as a service. Infrastructure as a service. So we need to be very clear. Okay, when I go to the Microsoft Azure, when I go to the AWS, when I go to the Google, so what are they providing it? And they are providing infrastructure as a service. It means they've built data centers and they are providing you infrastructure as a service wherein we can go and create a virtual machines and other applications and other necessary resources which is required to run our own applications. So this kind of models, we call them as an infrastructure as a service. So another kind of service called as a platform as a service. What happens in a platform? This is there quite from so many years. So we have a website. So many organizations will have their own website, okay, which they want to make themselves presence on the internet and say that, oh, I am this and I provide these kind of services. What do we do now when we are basically want a website? We don't build a server because it doesn't need a huge resources to run a website. It's a small application. So we go to the providers like GoDaddy, like Net4India or RDS or an Hostmaster. Like there are so many providers across the globe. So what do? They just create a space on a server and ask us to run or deploy our own application. Deploy our own application and run it. So here what happens now? We really don't know what is the server, what operating system it is running. We really don't know what web server it is running because in order to run the website, you need a web server. We really don't know. What we are doing, we are uploading or we are transferring our application, that is website application, and the data which is associated with that to some else. Now they manage everything. We manage our application. There is an issue in the application. We are responsible for it. There's some issue with the data. We are responsible. But running that application is the responsibility of the provider. So what happens in this case of a platform? The physical infrastructure, virtualization infrastructure, and an application runtime infrastructure is being maintained by the provider. So the provider will maintain all these things. So what makes a difference between an infrastructure as a service? In infrastructure as a service, we are maintaining only physical and virtualization. They are basically maintaining physical and virtualization. In a platform as a service, they are responsible for physical infrastructure, virtualization infrastructure, application runtime infrastructure. That is nothing but a middleware. Like might have heard about something like a web servers like an Apache, a Tomcat, okay, WebLogic, WebSphere, and IaaS, like many applications, okay, and run these. So what happens here now? So we manage, a customer has, it is a customer application. There is nothing but our application, our data. So we manage our application and we manage our data. So we simply upload our application into the provider infrastructure and we run our application and we manage our data. Now the provider does not have a control on the application, does not have a control on the data which is sitting inside this one. Okay. So this kind of these things where we don't need to bother about the server maintenance, operating system maintenance, and everything. But here, when you see that we have a virtual machine, we are responsible for operating system, application, and data. But in platform as a service, we are not responsible for this OS, which is sitting inside the VM. We are just going to deploy the application and data. So these kind of models, we call them as a platform as a service. So Microsoft Azure and AWS, Google, they also provide this called as a platform as a service models. So if you have a small website or application, you want to run it. So you don't need a server. We just go and upload our application into their platform as a service model and we run it. Those kind of things we call as a platform as a service. Now, other kind of a model which is called as a software as a service. What happens in a software as a service? The provider is responsible for physical, is responsible for virtualization, is responsible for the application, is responsible for and he provides the data, application, and data. Infrastructure. So he is responsible for virtual physical infrastructure, virtual infrastructure, application infrastructure, and data. Now we are not responsible for anything. Now what is here now? It is not our application. It is the application provided by the provider. It is a ready to use application which is provided by it. It's just simple like your ready-made shirt. Ready-made shirt. You're not buying the cloth. You're not getting it stitched. You're just going into a store and you're just selecting your color and the size, and you're basically getting a trial, and seeing that whether it fits to you. Then if it fits, then you choose it. You're just ready to use it. So here also what happens is in a software as a service, everything is being maintained by them. You just use that software. Now we are using a Gmail from so many years. So we don't know what is the software behind it. We don't know what servers are there. We don't know where that application is being running. We really don't know anything. What we are doing, we are saying www.gmail.com. We are creating our own account. And basically, we have started communicating with the world and storing all our data and everything inside the Gmail. Now here, software is not mine. I don't know what software it is. I don't know where it is being hosted. Nothing. I'm just simply using it. Simply using it. That is a software as a service. A Gmail is a software as a service. Like that, there are so many applications in the world. There are providers who are providing the software, providing a software. Earlier, SAP application, I need to buy the SAP. I have to install the SAP application in my data center. Then I have to maintain it. But today, a software as a service model, I don't need to buy the software. I don't need to install it in my data center. I don't need to manage it. What happens? I simply go to the SAP cloud, create an account in SAP cloud, and start using the SAP application. That's it. I don't need to bother about the maintenance of the server, regular patching, monthly upgrading, yearly upgrading, all these things I don't need to bother about. I simply keep using the application. That's it. That is called as a software as a service. Now today, many of the vendors provide software vendors. They are providing their applications on a software as a service platform. Software as a service. So Microsoft has 365. So Microsoft 365 is a software as a service model, whereas Azure is not a software as a service model. Microsoft Azure is only an infrastructure as a service and platform as a service. Now Microsoft has many applications, like 365 has an email service, as the Teams, Word, Excel, PowerPoint applications, a Visio application, project application, development applications. They have so many software. Now they're all providing it in a software as a service model. We just need to create an account in 365. I can start sending emails, use the Teams account, SharePoint, and other applications. Similarly, Google is providing a Google Apps. Zoho is providing a Zoho Apps. Like there are so many vendors who are providing a software as a service. So in a software as a service, application is not ours. Infrastructure is not as ours. Everything is being maintained, provided by the provider. We as a consumers, we only use the application. As long as it suits, we pay. Now, how does they going to charge? It all depends on vendor to vendor. Microsoft charges in a different way. Google charges in a different way. SAP charges in a different way. Oracle charges in a different way, because it all depends on the application to the application, how we are. Now, some vendors, providers will charge like a per user basis. If 100 users are going to use the application, they charge for 100 users on a monthly basis. Okay, if some vendors will basically based on the storage capacity, like you are going to use a 2 terabyte of storage, so you're going to charge for a 2 terabyte storage on a monthly basis. Like there are different ways of pricing based on the software to software and what kind of an application you're trying to use this. So these are three different kind of models available in the cloud. So it all depends on requirement to requirement. As I said, Microsoft Azure is more into infrastructure as a service and a platform as a service. Whereas Microsoft has the 365 cloud, which is basically provides a software as a service. So we have to be very clear, because so Microsoft has two different clouds. One is an Azure as a cloud and 365 as a cloud. These two are two different kind of platforms provided a different kind of services. Now people will call public cloud, private cloud, then hybrid clouds. So there's a lot of confusion here. What does it mean by a private cloud and public cloud and basically a hybrid cloud? We'll take a simple example for this one. So there is a small organization. So around there are 300 plus employees working in a night shift. Now the organization want to provide a transport service for the employees so that they can be picked up in the maybe in the odd hours, like in 7 o'clock, 7 p.m. in the night, and drop them at early morning in the 4 o'clock or a 5, where a public transportation is going to be a problem. Now the organization want to provide a transport service to the employees. Now, what is required for an organization? They need a cabs, they need drivers, they need basically people, and a system to manage this entire things. So now what happens now here? So I hire a 20 cabs or maybe and 50 cabs and hire a drivers and put a manager and put an application saying that, hey, whoever wants to go there, they have to book it. Now, what is the challenge with this one? I have to manage my own cabs. I have to manage drivers. I have to, my manager has to manage all these people. I have to have all this system. Now, I as an organization, having a 20 cabs and having a 30 plus drivers and basically sitting up and providing a transport service to my employees. Now, who can use this transport service? Only my employees. Outside people cannot use this. This 30 or 40 cabs which are being, or basically taxis which are being hired only for my employees. It means only my employees can use this cab, not outsiders. That is something private. So what is the advantage now here? Only the employees of the organization can use the transport service which is being set up by the organization. But what is the challenge for the organization? They have to manage the cabs, they have to manage the drivers, they have to have the system in place, they have to track it, who is going at what time, which cab, who is dropping it, security, like many other things. That is something called as a private service. Now, in a private cloud, what does it mean that? I'm setting up my own data center, a cloud data center, servers, network, capacity, virtualization, applications, everything I build and give it to my own employees or give it to my own departments that, hey, we have built a cloud data center within the organization. Whenever you want to create a resources, you please go to the cloud.abc.com and create your own resources. So external people outside of the organizations, they are not allowed to use these cloud services. That is called as a private cloud. Now, when when an organization is having their own cabs, they don't allow an external person to travel in that. Right? Let's look at from a public. Now, what happens now? The organization want to provide a transport service to the employees. Now, organization said that we cannot have a cabs. Hey, you have a Uber or a Ola, so which is a public transport system. So anybody can use the transport service from Ola or Uber. Now the organization said that, hey, anybody who want to have a transportation, they can use a Ola or a Uber and they can get it reimbursed. Now what happens with the Ola and Uber? It is not to a specific organization. It is to the public. So the transport service provided by a Ola or a Uber is public. Anybody can basically book a cab and they can travel from one place to another place. So you pay it based on the number of kilometers which you are basically traveling. That is called as a public transportation system. Now, what happens in a public cloud? An organization is setting up a cloud data center and allowing anybody to use it. So I'm saying that, okay, hey, I'm providing an infrastructure as a service cloud. So I set up a cloud and I'm telling that, okay, organizations that, hey, you can use my cloud services. Anybody can use the cloud services. It is not only my employees, outside people can create an account in my cloud and they can use the service. It means that the cloud services which you are providing is to the public people. So you are selling it, you're doing a business. Now, Ola, Uber is doing a business by providing a transport service by booking it. Similarly, here, the public cloud can be used by anyone. So Microsoft Azure is a public cloud. AWS is a public cloud. A Google is a public cloud. So anybody can go to the Azure and create an account in Azure and they can start consuming the services. Anybody can go to the Google Cloud and create an account and consume the services. Similarly, AWS, that is called as a public clouds because they have built a clouds for public. Any organization or an individual can go to these public clouds and create it. So what is these hybrid clouds? Larger organizations have a mix. They cannot go to the public. They cannot have private. They won't have a mix. Okay, some services they want to use it from a public, some applications they want to run it on their own cloud, which is called as a hybrid. So I'm using my own cloud, which is my private cloud, and some applications which I'm going to use it on a public cloud. Okay, so the combination of basically the integration between the private and the public cloud, which we are calling it as a hybrid cloud. So the hybrid cloud, partially we might have some applications running in our own data center and partially some applications running on a public cloud data centers. That is what we call it as a hybrid clouds. So now the organization can choose to set up their own cloud, which is a private cloud, or the organizations or the individuals can go to the public cloud and they can consume the services, or the organization can have their own data center and partially they can go to the public data center and consume the services. So where are we basically now? So based on the requirement, we can go with either a private or a public or basically hybrid. As a private, it needs a lot of efforts because we have to set up our own data centers, maintain it, give it our own customers. But as larger organizations like Verizon, like so many organizations, they have businesses across the globe and they have too much requirements. They will build their own private clouds. Okay. Right. So that's the overview about cloud computing. So in the next lesson, we will talk about the Azure overview. So what is an Azure? And basically we'll try to understand the more about the Azure.